Okay, hi again, everyone. We're now on page 29 of our statistics class notes. We're in chapter 3, section 3.1, where we're talking about numerical summaries for symmetric distributions. Okay, so in summary, using the mean to describe typical values. That's what we want to do, is to use the mean. The mean best represents a typical value in a set of data when the data is roughly symmetric. So again, don't get caught up in looking for perfectly symmetric. It's just as long as it's roughly symmetric. So how do we compute the mean? So first of all, the symbol for the mean is this. You have an X with a line over the top. You read that as X bar. Okay, for small data sets where we could do it by hand if we wanted, all you do is you add up all the data values, then you divide by the number of data values. So X bar equals this formula. Okay, now what does this formula mean? This is the Greek letter sigma, capital S in Greek. Okay, but it's sigma. In mathematical notation, since the Greeks were one of the first to do mathematical notations like this, we use a lot of the Greek letters. This sigma means add. It just means the sum, S for sum. So you add up all of the X values. That means add up all of the data values, and then you divide by N. N is the symbol that we will use in this entire class to mean the number of all data values in your sample data set. Okay, so N is your sample size. For larger data sets, of course, we don't want to do this by hand. Okay, so we'll let technology do it. We'll use StatCrunch in our class. All right, and I'm going to show you how to do that in just a second, okay? All right, so first of all, let's do it by hand. All right, so if we do it by hand, let's say in example 31 here, we have a sample of prices for a gallon of regular gas at 13 stations in Jacksonville last year. And we got all of these different values. So first of all, we could quickly create a dot plot of that data. So hopefully you remember how to do that. Just use graph dot plot in StatCrunch. I won't show you that again, but this is the dot plot. And then you can also have the dot plot actually plot the mean. So I had it plot the mean, which came out to be $2.46. Now notice this is not unimodal symmetric, right? We have a lot of values over here, and then we have some outliers to the left, okay? So I wouldn't call this symmetric. It's either skewed left, or you might call it symmetric, but there's outliers to the left, so we don't want to do the mean when there's outliers either, okay? So how do we do this by hand anyways? I just wanted, and this was just because it was a small data set, I just wanted to show you how the mean is not a good representation, but you still can compute it. So we compute it by hand, just add up all the numbers. So $2.35 plus $2, let me show you at the same time, plus $2.35 plus $2.36 plus dot, dot, dot means just keep doing that. I don't want to write it again. All the way down to the last number in the data set, $2.51. Divided by 13, the number of data points in our, that was the number of gas stations in our sample data set, and you get $2.46. Now that's rounded. It was like 2.46 something something, but it rounded to $2.46. All right, interpret this mean. So we always want to interpret the mean in the same way. We say the typical value of that data set. So in other words, the typical price of gas at these 13 stations in Jacksonville last year was $2.46. How would you characterize the shape of this distribution? Well, we've talked about that already a little bit. But hopefully you would say it's left skewed, unimodal, possible outliers to the left, data sets too small to know really for sure, okay, whether that's, it's a data set of 13 is way too small. But and if we're looking at that and we had to characterize it, you could either say left skewed, or there's, it's symmetric with outliers to the left. It really doesn't matter, it's as long as we get the point across. The mean is not the best measure of a typical value here, as you can see. I mean, right here we have 1, 2, 3, 4, 5, 6, 7 out of our 13 gas station prices was this value. Now what was that? Looking at the data set, it was $2.49. So $2.49 is a much better representation of our typical value than $2.46. So the mean is not the best measure of a typical value. Actually the mean was 245.8, right? So this 8 rounded up to make it 246. So how could you compute the mean? You just go to Stat, Summary Stats, Columns, then choose the column into which you type the data, then choose Mean and hit Compute. I will do that in a little bit. I'll show you on StatCrunch what I mean by that, but there's the steps. If you ever forget, just put them right there. I'll show you in a little bit. Okay.